Welcome to AI Enigma by IngramMicro.
The word enigma in the dictionary means something mysterious, puzzling, or difficult to understand. So, the question we are going to answer in this series, do we really think artificial intelligence is an enigma? We in IngramMicro believe that artificial intelligence is not just a technology or field of science, it's the new way of doing things. That's why we are here to talk about artificial intelligence from several points of view. Not only the technology, but also the need for artificial intelligence, the perception of artificial intelligence, and how we should live with it. And also, what are the ethics required to use artificial intelligence. We are here also to discuss the challenges of applying artificial intelligence in our business and even in our personal life. My name is Dua Yasin from IngramMicro.
And this is Tamer Al-Fattah. Let's first decode the AI enigma. In the past few years, various forms of AI have begun to creep into our daily lives, whether we know it or not. It's being used by major companies to improve their services and make their processes more efficient. Less than 2 years on, and we see AI being widely used in industries like retail, finance, healthcare, automotive, public transport, and many more. As the possibilities becomes more clear, the problem-solving potential increases. This widespread adoption of AI is likely to continue. AI will not only assist us in carrying out various tasks and making better decisions, but increasingly will perform the task autonomously and replacing us as a result. But what do the public think of AI and why it is important?
AI Enigma by IngramMicro is a big umbrella to decode the AI, build the AI community, give market insights, provide several solutions for different industries. We are also going to meet and interview iconic figures in the IT world, especially in artificial intelligence, and also explain from our point of view how to make business around artificial intelligence. We welcome all your comments and feedback. Starting with the AI different subfields. In the modern era of artificial intelligence, AI can be categorized into 4 main application subfields. Starting with computer vision, which is the machine's ability to understand visual context, either its images or videos. Natural language processing, which is concerned with the interaction between computers and human natural language. We have speech recognition, which is concerned with translating human spoken language into text, and we have robotics as well, which is the field of design and implementation for robots that can assist the humans in some of the tasks they are doing on a daily basis. On the level of technology enablers and algorithms, we have machine learning and deep learning. Deep learning is a subfield of machine learning. Both of them are behind the current revolution in the AI application. So they serve all other application fields, achieving accuracies never achieved before. Let's start with computer vision. Computer vision is concerned with the techniques and algorithms used with images and videos to develop solutions that can understand the visual context and act accordingly. One of the main applications in the computer vision area is object detection. Object detection is about localizing and classifying all different objects in an image. For example, here we can see different types of objects. We can see humans, traffic lights, car, truck, and many other objects as well. Object detection also comes at the core of many other applications like face detection, pedestrian detection, weapon detection, and it can serve many other use cases as well. Actually, not only deep learning and machine learning are the enablers for the current wave of solutions in computer vision. Research institutes and companies invested a lot in the data as well, which is the most important aspect in application development in the era of AI. Here we can see ImageNet dataset, which includes around 14 million images organized according to the WordNet hierarchy, and almost each class or node have around 22,000 images. Giant companies already in the AI field competed every year to win the challenge for ImageNet and build state-of-the-art architecture to achieve the best accuracy.
So I think all of us now can understand how machine can see the way we see. But what about our reading and our hearing senses? Can machine really understand the way we talk or the way we read? This is, I think, very important question. Here, this sentence, for example, says, "Hello, artificial intelligence world. Everyone here can simply understand in English and most probably in one or more of the other languages written here. Can you please explain to us how machine can do this? And especially that this is the way machine understand the instructions."
The way machine understand the human natural language is part from the natural language processing. Natural language processing is about the techniques computer use to process and analyze large amount of natural language data, and also understand the context of the data, extract the required information, and provide the right response accordingly. In order to process the natural data, huge research is being done to find the right representation for text data, and also to develop the right deep learning architectures that best fit the nature of the text data, as it introduce lots of dependencies. Usually, people think that speech recognition is part of natural language processing, but actually speech recognition is a different subfield of artificial intelligence. Speech recognition is concerned with translating human voice into text. Also, it's known as automatic speech recognition or speech to text. Speech recognition usually incorporates signal analysis, feature extraction, acoustic models to determine the phonemes, convert them into words. Some natural language processing models are being used at the end of this process to solve the context issues like language models and accent models. On the level of the virtual assistants we are living with and we are dealing every day with them, they have a combination between the speech-to-text and natural language processing to be able to act and provide further functionalities accordingly. When we talk about natural language processing applications, we start with sentiment analysis that help us to analyze the reviews and feedback. We have also topic modeling to highlight abstract topics within the text. We have text classification to classify the documents into specific and predefined topics. We have information extraction, named entity extraction as well. On the level of text representation, we now use word embeddings to represent the words with number vectors that can capture the similarity between different words. Moving to the robotics already have huge popularity even before many other artificial intelligence fields. They showed to be very helpful in many tasks and many different fields, starting with manufacturing, for example, and automating risky tasks as well. Robotics can be seen as the interface between the artificial intelligence and other engineering areas like electrical and mechanical engineering, and also control as well. Various applications of robotics in different fields include manufacturing, delivery, consumers, agriculture, and finally healthcare.
I think this is very interesting to understand about the AI subfields, in the coming segment, I will give us more technical overview about the artificial intelligence technical aspects.
I just mentioned modern AI, as artificial intelligence is not a new concept. Generally, AI is any techniques that allow computers to mimic human behavior. AI started in 1950s. Classical approaches of artificial intelligence included expert systems, planning and optimization tasks, but it was limited to specific areas, as this requires thousands of hard coding and rule-based algorithms. Machine learning introduced a new approach for doing this, which is learning from data and previous experience, without the need for explicit programming. So, there is no longer need for thousands of code lines to cover all possible scenarios. Development in machine learning wasn't very fast initially due to the computational limitation. And finally, deep learning as a subfield of machine learning that builds multi-layer network that simulates the human nerve system. So simply, we can say that machine learning is the shallow network, while deep learning we can stack multiple layers into one network. Both of them have trainable parameters and learn by trial and error. When we talk about machine learning is always associated with two terminologies, supervised learning and unsupervised learning. Supervised learning covers learning from data with predefined labels, like we know the right answers before, like classification and regression, while unsupervised learning used to detect common patterns in data samples, like clustering.
We can see now that deep learning already caused the current AI revolution in the different fields. So what is the added value actually of deep learning? Machine learning requires a lot of feature engineering to extract features from the data and find the correlation, while deep learning don't require this. All you need to do is ingest the data into the network and it will learn the embedded features behind the data points. That's why deep learning best fit for unstructured data like images and text.
Okay, I think this is interesting to know about the deep learning, but I think very interesting question here is why we still need machine learning.
We can see now that deep learning is behind the current AI revolution in the different application fields. So what is the added value of deep learning? Machine learning requires lots of feature engineering to extract features from the data and find the correlation, while deep learning don't require this. You can just ingest the data into the network and it will learn the embedded features behind the data points. That's why deep learning best fit for unstructured data like images and text.
Moving to the GPU computing, we always mentioned that computational power has always been a challenge for machine learning and deep learning development. Training a neural network with a CPU may take weeks to months based on the complexity of the network. The advantage of GPU over CPU that it's optimized for parallel tasks, having thousands of cores, while still best CPU will have tens of cores, for example. That's why the GPU can process and render high-resolution images and videos, and other matrix multiplications as well. That's why it best fit for deep learning training, which incorporates dealing with matrix multiplications and many other matrix processes. And here on the right, we can see the difference in the performance between the GPU and the CPU.
This AI software is used to classify different types of flowers. First, when we talk about the CPU performance, it can achieve up to 5 images per second. When we use one of NVIDIA GPUs, which is Volta V100, it can achieve up to 900 images per second. And if we use 8 Volta V100, it can achieve up to 7,000 images per second. And here we can see the difference in performance between using GPUs and CPUs.
I think we already covered the main terminologies for artificial intelligence that we deal with on a daily basis. Talking about the ecosystem for artificial intelligence, we can't ignore the investment and progress in providing the complete ecosystem to support the different application fields, starting with the GPU themselves, then the GPU drivers that can run them,
Then we have deep learning SDKs, and finally the different frameworks. Most of them actually are open source frameworks that can support the development of artificial intelligence applications.
Okay, thanks a lot, Dua, for this information. Let's have a quick look about the market opportunity and how the market is perceiving artificial intelligence in general. And here, if we're talking about the market opportunity, definitely the market opportunity of the AI is massive. We see here some reports and studies by some market analysts like IDC, McKinsey, are talking about the market size, the adoption of the artificial intelligence, and also the return on investment for AI in different segments. We thought these numbers and these studies are very beneficial for you to know with us as well how the market is seeing the artificial intelligence, because at the end, this is what we seek for, what exactly we are after as an opportunity. IDC, for example, predicts spending of artificial intelligence to be more than $77 billion in 2022, which is 3 times the spending in 2018. And KPMG had done a very interesting study worldwide in 2018 on sample of 590 enterprises, and in all AI subfields. More than 50% of them are either already implemented or moving to production or even in piloting phase. This percentage for sure increased big time, especially after the COVID-19 situation that we live now, where AI solutions are used in many areas to either detect or used to even do research and development for discovering vaccine or even a medicine. Another point of view that McKinsey made, they have done also a study about if at least one AI functionality is already embedded in the enterprise operations. And as you see here, the adoption is all over the planet. Developing markets, for example, including China, are more in computer vision subfield. Europe are more advanced in the RPA and different categories of NLP, the natural language processing that Dua has just talked about, how the machine understand our way of talking. And this way is these things are growing big time. A fourth point of view that we see here, how about the return on investment in the AI solutions from the industry's point of view? And this is very important point to understand for all of us. It is clear that ROI is high in technology-based industries like telco, entertainment, technology services, but even better in the industrial products and services where investments even are not that high compared to the return. Okay, I was saying that in this slide I was talking about the market opportunity. And the market of opportunity of the artificial intelligence, I was saying it's a really massive opportunity, as we all see. We see here some reports and studies by some market analysts like IDC, McKinsey, are talking about the market size, the adoption of the artificial intelligence, and also the return on investment for artificial intelligence in different segments. IDC, for example, as you see here, predicts spending on AI to be $77 billion in 2022, which is 3 times the spending in 2018. Another point of view that KPMG is giving, they have done a great study worldwide in 2018 on a sample of 590 enterprises. And in all AI subfields, more than 50% of them are either already implemented or moving to production or even in piloting phase. This percentage for sure increased big time, especially after the COVID-19 situation, where AI solutions are used in many areas to either detect or used to R&D for discovering vaccine or even medicine. Another point of view here that McKinsey offered, and it's also very interesting research they have done, they had done a study about if the enterprise has at least one AI functionality, and they have already embedded this in their enterprise operations. And as you see, the adoption is all over the planet. Developing markets, for example, including China, are more advanced in computer vision, Europe is focusing mainly and advanced in the RPA, robotic process automation, and different categories of natural language processing are growing as well, as you see here. Fourth point of view, how about the return on investment in the AI solutions from the industry's point of view? It is clear here, as you see the different quadrants, that the ROI is high in technology-based industries like telco, entertainment, technology services, but even better the industrial products and services, where the investments are not high compared with the return. For the next slide, as you see here, we were talking about different examples for the use cases applicable in different industries. If we're looking at the construction, for example, you will find that there is, of course, a big area for the robotics. Quality and inspection now is being done using drones with computer vision implementation on it, which can do the proper inspection without compromising lives or people safety. Autonomous car, of course, this is a big market, as you know all. Customer service, and this is a big area for the natural language processing as well, and also the computer vision if we're talking about the sentimental analysis thing. Security and energy efficiency in smart cities are main use cases. Those are big business today in everywhere. And also now security is not just doing a surveillance with the CCTV cameras to record the videos. The video analytics, and here when we're talking about video analytics, we're talking about the AI features to extract the different types of features of the objects, abandoned objects, people, face recognition, and many other things. Agriculture industry also is one of the industries that has several use cases that artificial intelligence have been implemented in, like crop management and disease identification. And we will talk about some of these use cases in the coming slides, also to understand more what is the role of the artificial intelligence in these use cases. And in the next episodes, we'll do some more focus about specific areas like the smart cities, cybersecurity, customer service, and different other areas as well.
Tamer already mentioned that artificial intelligence is being applied to all industries, almost all industries. Let's start with the healthcare sector. AI already can help in the drug discovery to decrease the development time. Deep learning is being used to analyze and extract information from the genome sequential data that can help a lot in improving the overall development cycle of the drug discovery. Also, AI can help in the clinical trials by identifying the right patients for the clinical trials using natural language processing to analyze patient data. Also, it can improve the trial documentation and summarize all required procedures. When we talk about lung cancer detection, AI can provide early detection of lung cancers by identifying the millimeter level nodules either in the MRI or the CT scans. Also, artificial intelligence can be used in skin cancer detection as well through doing a comparison between the normal skin and the skin cancer, the skin with cancer. Also, AI can help in the immune system analysis through identifying the number of white blood cells through computer vision. When we talk about the automotive sector, we already mentioned object detection. We have also semantic segmentation to group all the instances of the same class into one group for the sake of scene understanding. We have also lane detection, and all of these applications are important for driver assistant applications area and self-driving cars as well. We have also license plate recognition that can support reading different types of license plates and can be customized to different countries and regions as well. we have speed detection, and we have traffic management and traffic analysis, and of course object localization as well. On the level of security, surveillance is one of the cases that spread so fast due to the ability of the CCTV cameras. Applications in surveillance can be very important for use cases like border control, military and defense, security for public places, gated communities, enterprise buildings, and so on. For example, intrusion detection can be used to identify the place of intrusion and the person who is getting to an unauthorized area. We have also threat detection to identify the watch list of criminals, for example, and identify if there is any kind of weapons. We have abnormal behavior detection, where in this case the machine is trained to the normal behavior, and then it can give alerts for any abnormal behavior. We have also people tracking and identification, and object tracking and re-identification. On the level of retail, we can start with machine learning, predictive analytics for demand forecasting. We have also warehouse optimization to improve the logistics scheduling, shipping accuracy, reduce overstock, and improve the risk analysis. We have customer behavior analysis to identify if the customers are satisfied with the products and services they are getting. We have sentiment analysis through emotion evaluation. We have also people counting, heat maps, attention tracking. And also we have demand forecasting and assortment optimization as well. On the level of manufacturing, robotics has been used for automation tasks and complete dynamic environment. Predictive analysis also is very important for the early detection and prevention of machine downtime to reduce the cost and improve the overall efficiency. We have also defect reduction to reduce the defects of the final products and standardize all the products, and we have 3D vision inspection. And finally, for our current situation for COVID-19, actually this situation introduced lots of challenges for doing the normal activities that we do on a daily basis. And now there are lots of challenges getting back to normal life, assuring both safety and business continuity. There are lots of regulations have been applied on the government level, and also there are lots of precautions that we need to make sure that we can stop the spread of the virus or mitigate the spread of the virus. This solution can be applied to all public places, governmental entities, any places, malls, for example, bank branches, any places that can receive people coming in and out, and there is lots of interaction between the people. This solution provides automatic detection for people with high temperature, giving alerts for people with fever, and it can reduce the manual checkpoints for temperature measurements that sometimes can introduce cross-infection and huge waiting lines. We can also detect other symptoms for COVID-19, either coughing or sneezing, and all the data can be integrated into a centralized database. We can also detect the required regulations for COVID-19, like wearing a mask, which is becoming regulation in many countries, for example. We can detect if people are compliant to wearing a mask or not. At the same time, we can assure the social distancing through using computer vision technology and give alerts for people who are not compliant to social distancing. And finally, we can do the people counting to assure the occupation and the capacity of closed retail stores, for example.
Okay, and now what the most important question is, what's next? So today, this is a warming up session to talk about the basics of artificial intelligence, to talk about the public perception of AI, how it is important, how it will drive the future of research and development of AI, how it will drive our business, People today are not only have fears of losing their jobs, but also there are lots of other concerns about the data privacy, about the other stuff. Where exactly the AI will come? Is it opportunity or a challenge? These things are very important. What about the cyber attacks as well in such world? These things are on top of the list from issues point of view. With that, we come to the end of the slides that we have for AI Enigma, and we will open now. We will welcome your questions as well to make some interaction as well. Before that, we also want to invite you to join the next episode, where we will have different subjects as well, and different and new guests of honors from iconic figures in general in the artificial intelligence area. And in next episodes of AI Enigma series, we will learn more about the other challenges of AI, how these challenges are addressed, how it's shaping the future of different areas as well, other than the AI, like the normal IT, the cybersecurity, the data privacy, the data management, and many other topics that we are preparing for you to have a 360 view about the artificial intelligence.